Good evening, everyone. Thank you for joining us tonight for our RiverWatch Fall Speaker Series. For those of you who are not familiar with the Illinois RiverWatch Network, RiverWatch is a citizen science organization that trains volunteers to monitor water quality in their own communities. The mission of RiverWatch is to safeguard the future of Illinois rivers and streams through stewardship, education, and sound science. If you are interested in becoming a citizen scientist, please consider coming to one of our spring workshops that will be held in person across Illinois. Before we get started, I ask that you keep your microphone muted during the presentation to limit the distractions. We will have a Q&A session after the presentation, so if you have a question along the way, you can either put it into the chat box to be answered at the end, or you can save the question to be asked aloud. Now I would like to introduce tonight's speaker, Dr. Jenny Mullikin. Jenny went to Bradley University for her undergraduate and master's degrees, where she studied the effects of garlic mustard on soil processes. After that, she worked for an ecological consulting company where she did wetland delineations for a variety of projects across the Midwest. Jenny most recently came from St. Louis University, where she studied diet specialist bees in urban environments for her PhD work. Currently, she is working at National Great Rivers Research and Education Center, where she is in charge of the new Wetlands initiative that will combine the expertise of the other senior scientists into a collaborative research program. And with that, I'd like to welcome Jenny Mullikin.
Cool. Well, thanks, everyone. I'll go ahead and start sharing my screen. And there we go. Like she said, this is kind of a mashup of what I did and what I'm going to be doing at NGRAC, and how almost kind of selfishly how I relate them in my head. So it's nice to put this all on paper. And so we're going to learn about wetlands, we're going to learn about bees, and just have fun with it. There's a lot more we can talk about, so if you have questions, I'd be happy to expand on any of this at the end. So like I said, we're going to go over some wetland basics, some pollinator basics, how wetlands support pollinators, and then some urban ecology and pollinators as well. So wetlands really are transitional areas. It's that transitional zone between a terrestrial system, dry land system, and an aquatic system. And usually the water table's at or near the surface, or the land is covered by shallow water. So these are just some classic pictures what we think about when we think of wetlands, with kind of marshes or lotus flowers covering kind of a water soaked bottom. But they don't always have to be that. Really, there's different classifications of wetlands depending on who you talk to. If you're the coordinate classification, if you're going by that, like kind of standard, that kind of a lot of government agencies kind of base their understanding of wetlands on. It just needs one or more of the following attributes. But if you're the Army Corps of Engineers, it needs all three. So first of all, we need hydrophytic vegetation. So just water-loving vegetation. And some of these examples over here, when you think of wetlands, you think of cattails, lotus, bulrushes, these Sagittaria, duck potatoes, which is just one of the best names for a plant ever, and some pickerel weeds as well, just some of my favorites. You also need hydric soil, and the substrate, again, that's saturated with water or covered with shallow water for some time during the growing season. It doesn't even have to be all year, but those three are what we're looking for. And I won't bore you. I think soil is really interesting, but I won't bore you with all of the details. But when we're thinking about a wetland soil, this is kind of what it looks like. There's a lot of different ways it can look, but these are just some of the more common ones you might see on Illinois wetlands. So the USDA put out this field indicators of hydric soils, and they all have different names, but really I like to point out this redox dark surface, these kind of grayish brown soils, but with these really bright rust colored spots. And that's just how, if you leave your bike out and it rains, it might get rusty. The same thing is happening here. The iron in the soil is experiencing wet and then dry periods, creating that rust effect in the soil as well. You can also have really dark soils that are really just holding on to all that biomass, giving them that really dark color. Or on the opposite side, you can have really gray soils that have all the nutrients and all the carbon has really just been like leached out of them. But we just check for different indicators and move about our day. Just because the colors tell us enough of what we need to know. Soil processes are on timescales of like 10 plus years, so we don't get any deeper than that. So some wetlands that you might run into in Illinois, wetlands types, they're all wetlands, but they're really classified by either the vegetation, the precipitation, or water source, or a combination of both. I'm not really going to get into the water sources because really that just depends. You can't really tell that from a photo. It kind of depends when you're out there and looking at the landscape. But we can classify them by their vegetation a lot of the times. With that first classification being emergent wetlands. And so these are ones with herbaceous layer. They maybe have a few shrubs, but really it's just that herbaceous layer that we're looking at. So in Illinois, we might see farmed wetlands, wet meadows, or marshes. One of the best examples of a restored wetland is that Emiquon in Banner Marsh up near Peoria. Definitely worth checking out, especially now with bird migration time. It's pretty great. And the opposite of emergent is really a forested wetland, where it's dominated by trees. Again, a few shrubs, but mostly trees. And in the southern part of the state, in the Cache River State Natural Area, or the Shawnee National Forest, you're getting these cypress tupelo swamps, which you can see in that photo on the left, just those knobby knees coming out of the water, and beautiful green trees. So definitely worth checking out as well. And so I stole this photo that explained the functions and benefits from the North Carolina Wetlands Society, just because I couldn't say it better than they could, and it looks nice. So, I mean, I think all of us here appreciate wetlands, or at least can recognize their value. But specifically, they do have a lot of functions and benefits. They have a lot of ecosystem services that we scientists call the things on the right side here, where these are really inherent to the ecosystem, and they provide benefits to us. So with flood and erosion control, they're really good sponges. They're going to be able to hold on to water in a rain event and make water not flood, but also make it not so flashy, so they can slow down the velocity of the water, because it gives them a place to at least stop if it's overflowing. It can also slow down the soil with that erosion that comes with flooding and flashy water. It also cleans the water. The water that settles in the wetland might come with some pollutants, contaminants, and so a lot of those settle out into the soil before they move on to a moving body of water. So it's really great natural water filter. And then it slowly releases water to the groundwater. Usually it's a great source of groundwater recharge, because a lot of wetlands, their water table is really close to the soil surface. So there's a really good interchange there. And so by having a lot of wetlands there, you're giving a space for groundwater recharge and also groundwater filtration at the same time as it goes through to the groundwater. And then on the fun side of things, other things that we can more readily see, they're a great source of food production for us, you know, shellfish, crayfish, but also food production for other animals. Birds are great nest over or fly over nesting sites for migrating birds. Also for insects, and we're going to talk about bees later, but insects, mammals, you name it, I'm sure there's an organism that can benefit from a wetland. And they're fun. I like to go hiking, I like to go fishing, boating. And so some recent, just came out last year, a 12-year study in Illinois was looking at some constructed wetlands. So I'll get into wetland declines in a little bit, but now we're just like with prairies, wetlands also in Illinois have been converted to ag by either tile drainage or filling, or just trying to farm straight through them in dry years. But a 12-year study from the Nature Conservancy on constructed wetlands in Illinois found that even just a small wetland, which is 6% of the tile-drained agricultural area, can reduce the nitrogen in the runoff of the field by almost 50%. And so these are showing this figure I took straight from the paper from Lemke et al. Showing, I don't know if you can actually see my, there we go. These three constructed wetland basin areas were the ones that were able to pull off nearly 50% of the runoff of reduce the nitrogen by 50% in the agriculture area. It was just amazing, 6%. So they can, a small area can do a lot of good work. Oh, how do I erase those? How do I clear them? Erase it. So I've never used the annotate function in Zoom. Okay, so declines, I know this has a lot of words, but wetland decline has been pretty steady since we've cleared wetlands for agriculture or for development. But since the 60s and 70s, there's been a decrease in the amount that we're losing, if that makes sense. So by 1984, so about halfway into this figure, over half of the wetlands in the US have been drained or filled for development or agriculture. And before that, we were losing way more wetlands per year, and it was really because of these acts, these policies that were put in place. The first one in 1977 with Jimmy Carter, so that can really take care of, we see that first jump in the decrease of loss. Next with the Farm Bill in 1985. In 1989 with the no net loss of wetlands, we see another decrease of loss in wetlands that we're getting. And even in the 90s, we see an increase of wetlands due to the wetland reserve easements in the Farm Bill. And it's just really nice to point out that, like, yes, we've lost a lot of wetlands, but through conservation efforts like this Nature Conservancy and through policies, we're able to see a recoup of that loss. However, this doesn't have anything to say about the quality of the wetlands that were put back, just total area, which is another issue to work through. And like I said, most of the wetlands that we lose are from either agriculture or development. And I didn't explain the last time, but the slides, these two pictures, two aerials that we see, like, are side by side. So what it used to be back in the 20s versus today. So even just on small family farms, we're seeing the decrease in wetland availability. And then they end up looking something like the photo on the right when they are developed and in urban areas. That's kind of another way to make an urban wetland. So other urban wetlands that we see, I'm working through, we're getting to the city part now. Most urban wetlands are really stormwater detention areas. And St. Louis actually has quite a few. I was able to take photos and go around the city, finding all the new construction areas or digging up old photos of new construction, because we're starting to see people care more about water retention and starting to see more construction in the St. Louis area. So it's nice to see that this is part of the plans when people put in new developments. So some are vegetated like these, some are not, but they actually serve a lot of purposes for water loving species. There's a lot of hibiscus in here, and I'll get to that later. There's a lot of insects in here. This top one at IKEA held so much milkweed that it was a stopover for a lot of monarch butterflies. So it's nice to see that urban wetlands can be a thing, even if they are mostly stormwater retention. Because they're stormwater detention basins, they can get a lot of runoff from the surrounding area with pollutants, with road salt. So they are not as friendly to all wildlife. I do have to make a caveat there. Insects seem to be fine, but I'm sure Danielle could tell me what other animals do not do well with the road salt runoff that goes surely into these stormwater retention areas. Other urban wetlands are rainscaping projects. The Missouri Botanical Garden and MSD Project Clear have great resources on if you want to create a rainscaping garden or rain garden in your property, how you would do that, all the options that you can do for rain gardens. Because it's all about slowing down the water, mimicking those natural ecosystem processes that wetlands give us in small spaces, in our yards, in our community gardens, in our parks. And so if we're just looking at slowing down the water and adding habitat for maybe some insects and small mammals or birds, there's a lot of different things you can do between making bioswales and rock weirs and different rain gardens, or even just soil amendments to naturally let the water kind of sit there. And there's also grants available for these too, but these are just other ways to get wetlands in a city that will eventually benefit more than just ourselves. So we know, I'm kind of transitioning now a little bit on wetlands now to the bee side of things. It will come back. They will relate to each other by the end of this. But we know from studies in St. Louis that a diverse assemblage of specialist bees is in the city, and just bees in general. And so some of my work was looking at how specialist bees thrive in cities. But now I'm going to figure out how that relates to wetlands with my new work at NGREC. But just some urban bee information. So in the entire world, the diversity of bees is about 20,000. As we move to North America, there's about 4,000. I'm on the Missouri side, so I always talked about Missouri being 452, and about in Illinois is about 500. But in the city of St. Louis is 209. So we're getting about a little under half of the diversity of the bees in the state, just inside the city limits. And these pictures are here just to show you the wide variety and diversity of bees that you can see just out your back door. I think it's pretty much the end of the season for all of these, except for maybe the bumblebee and probably just the bumblebee. Maybe the bee on the bottom right corner, I'm sorry, bottom left corner is a sunflower bee, but I think those might be done for the year, but you might still see bumblebees out. But you also get masked bees. The second to the left is a masked bee. It's a Hylaeus. These ones are really cool. They don't have any pollen carrying hairs, so they carry all of their pollen and nectar in their guts, and they regurgitate that back when they get to their nests. The middle bottom bee it's a leafcutter bee. It's in the Megachilidae family, and they've adapted pollen carrying hairs on the underside of their abdomen. So all that white hairy stuff underneath the black abdomen is actually pollen that bee has gathered. And then the second from the right, there's the bombus, the bumblebee. And then we have the cuckoo bees in the bottom right corner, which are really cool. They don't even make nests. They just parasitize others and use their work and use the nests of other bees by planting their eggs in other bees' nests. And then on that green metallic bee is in the sweat bee family. They're a dime a dozen in the city, and I just love adding these ones to show that not all bees are black and yellow. There's so many cool metallic bees out there. So how do bees thrive in cities? They start by finding what they need in cities. So kind of what I alluded to on the last slide, bees need food, which for them is pollen for their larvae and nectar for adults mainly. And there's a few different ways that they get that. If you're a hibiscus bee, you get it from the hibiscus, and you cover your pollen carrying hairs. This is actually a male, so there's not any pollen carrying hairs in there, but usually they pack the back legs of the bee full of pollen and transport it. Or you can be a bumblebee, that second photo of the bee, and you pack the your pollen pants, your pollinia in, and you carry that off to your nest. So when we talk about pollen pants, that huge yellow shape on the bumblebee is what I'm talking about. There. And then they also need shelter, which for them are nests. So there's three main ways bees nest, either in cavities. This is a picture of my bee hotel. So you can buy these at the store, but be careful who you buy it from. But there's cavity nesters. They will also, in nature, they would nest in pithy stems. So it's important to leave, if you have an area of your garden, to leave patches of tall stemmed plants over winter, because likely those might already have nesting bees in them, or they make great habitat next year for nesting bees. The majority of bees nest in the ground, about 70% of bees nest in the ground, and you can see this bee poking its head out of its ground nest as it's trying to close it up. And then other bees nest in cavities of dead wood, like bumblebees do. There's other sand nesters that kind of technically are ground nesters. Wide variety of things. They just need a safe place to put their eggs and pollen. So in a city, bees call many different urban land types home. So home gardens, vacant lots, parks and natural areas, community gardens and farms, anywhere where there's a good amount of native plants and nesting material and water source is really where they're going to be happy. And it doesn't take a large area. Like I said, home gardens and vacant lots, those are small spaces, but they can really support a diversity and a variety of bees. But what I found in my research is that urban wetlands can also act as pollinator habitat, especially for wetland dependent bees. So these two detention basins, they don't look like this anymore, but they were part of my research sites because they had hibiscus bees all in them, and quite a big population of them too. So they can, and then also ones that are full of water can also act as an important water source because they do need water with their flowers as well. So, like I said, water, a lot of beeswater use depends on human inputs in cities. So not just the constructed wetlands, but also the water that we water our yards with. So on the right, it's just puddles from people watering their lawns. There is a stormwater management basin, but also a dog bowl from a dog park that the bees, the hibiscus bees, are actively in the dog bowl getting water. And then also on the left, there's actually like a stormwater pipe, an outlet pipe that you can't see in the photo, but it's pushing out puddles of water into a part in the grass. So all these water inputs, not always wetlands, but always important to support the bees that are out there. And I'm not to say that you should be watering your lawns all the time or leaving out dog bowls of water, but it is something to note when we talk about bees in cities where there is, we've created impervious surfaces and other surfaces that don't really hold water. And so these inputs are kind of necessary in order for a variety of bees to exist. And speaking of variety of bees, there's quite a few that are specialized on specific types of pollen for their diet. And a lot of these are specialized on wetland dependent plants. One of the biggest ones are the willow specialists. I didn't even put all the Andrena bees that rely on willows, but the willows are one of the first plants to flower in the spring, and they're a really important host for a wide variety of bees. There is an Andrena illinoisensis for all of you from Illinois. I thought that was a fun species name. And again, you can just see all this bright yellow pollen that the Andrena has collected on her back legs to bring to her nest. Some of my favorites, the blueberry cellophane bees, they are specialists on blueberries and other vexilliums that are bog style plants that live in bogs. And just to show, I love this photo on the right, you can see how small some of these bees are compared to somebody's fingernail. More of the summertime bees, Macropus nuda is a specialist on loosestrife, and they are special. They actually grab the oils from the plant as opposed to the pollen and nectar. And again, you can just see how small these little ones are compared to somebody's fingernails. Duphora novae, so they're a pickerel weed specialist. They're really small, just impressing on, I love just adding photos of bees and showing just how small they can be and how, until I started, I know for me, when I started looking at bees, how much I realized I passed over the small ones until I really started paying attention and looking at what was there. And again, these are more of a summertime bee. And then this is my baby, the hibiscus bee. This one is found. Some of these the wetland specialists I just showed, some of them are found in cities. This particular bee, the hibiscus bee, is more often found in cities than in rural areas because of those human inputs and because the stormwater detention basins are vegetated with hibiscus, and people enjoy planting hibiscus in their yards and they water their yards. Cities have really made ideal conditions for these bees to thrive. And the other cool thing about this bee, because it specializes its diet of pollen on hibiscus, its legs are, its leg hairs, its scopa are also specialized to kind of hook onto the pollen, like a Velcro situation. And it's just really, really pretty. So that's kind of all I have. You kind of an overview of bees and wetlands and everything, but just a few points to leave you with. Just the many different types of wetlands in Illinois, and they're defined by their water source and vegetation. But again, we usually just look at their vegetation unless you're doing some serious research. Wetlands are also found in urban areas, mostly constructed wetlands for stormwater storage. But they can also support a wide variety of plants and animals, including the bees. And specific bees specialize on some wetland plants. So if you want to help the bees plant native plants, and if you want to help the wetlands water storage, create a rain garden in your garden. It doesn't have to be big. Any little bit helps. And with that, I can take some questions.
All right, thank you, Jenny. That was a great presentation. If anybody has any questions, you can now unmute yourself to ask or put them in the chat. And James did put one question in the chat so far that says, does the cleansing function of wetlands mean they become increasingly toxic over time?
That's a good question. I think if you dug up their soils, there might definitely be some toxic metals in their soils. There's other plants that also can uptake those heavy metals. A lot of the cottonwoods and sycamores, some of those fast growing trees people plant for photo remediation. Yeah, I'd have to, that does make me curious, the heavy metals and toxicity of wetlands over time.
I see, James, you unmuted yourself. Did you have more to add or something else to ask?
No, well, it's just something I've always wondered about, that toxicity question. But also, I just want to mention to Jenny that there's a halictid that I keep seeing on asters, of which I have a great abundance in my backyard.
Oh,
And,
nice.
So that's another late thing. I'm not sure what it is. It's a slender bodied, I think, halictid. It looks like, I just don't know which though.
Yeah, Nina might know. Nina's gotten really good at her BID and has had to go through all the
I've got a few pictures. Maybe I should send them to you.
yeah, that'd be great.
Okay.
And then Patricia asked what type of nests / where do wetland bees make their nests?
Yeah, so they'll make I'm more familiar with ground nesting bees. They'll usually nest right next to the wetland, but more on like a drier spot just outside of it in the uplands section. A lot of bees like compacted soil. So like out at Shaw Nature Reserve, and actually shout out to James Traeger because he was the one who noticed it maybe 6 years ago at this point, and that's how I started looking at the Tylotrix bombiformis, the hibiscus bee. So they nest in a compacted dry soil just outside, and it's actually things like walking trail, walking paths that have been compacted over time, or it's something like where dogs would, like they're in the dog park because dogs run around and compact the soil. So dry areas that are next to wet areas that don't actually get wet.
Okay, and then Joey asked, is there a Supreme Court case that is coming up that will rule on how a wetland is defined?
Yeah, it comes up every few years. The Clean Water Act is funny because it's administered by the EPA, but then the Army Corps of Engineers is the one who enforces it. So I feel like there's a lot of back and forth on what is defined as a wetland. More so, not necessarily the wetland, but what counts as an ephemeral stream. So a lot of the debate is what to count under the Clean Water Act, because it was originally made for navigable waters of the United States. So those ephemeral drainages or even ephemeral wetlands, they're trying to make not count under that law, even though that's where water quality really starts, is in those upper reaches of the system. So yes, there is, but I don't know how far they'll get, if they'll change anything.
And then Judith asked that you said that you have to be careful where you buy your bee houses. So what should you look out for?
Yeah, thanks for asking. You should look out for, so in nature, bees don't nest in huge aggregations in cavities. So you don't want any bee house that has hundreds of stems. You want ones that maybe have like 10 to 20 stems, just because that high concentration of stems is going to basically be a buffet to any kind of parasite or parasitic bee. So, and also ones that bees nest in specific sizes of holes. So usually I don't know off the top of my head the size, but the Xerxes Society has some information on a good size for holes for those stems in the bee hotels.
Okay, I had a question. What is like the main strategy that bees use to survive over the winter? Or what kind of, what do they do?
Yeah, so bees have like a 1-year life cycle. At least they do where we live. If you go to the tropics, that changes, and I'm not familiar with how that changes, but where we live, because we have winter, they have a 1-year life cycle. So in the summer, the adults are laying eggs in nests, and for most solitary bees, it's the female is laying the eggs on her own, and it's usually, at least for most of the bees, it's 1 nest per day for the hibiscus bee anyway. So it's 1 nest per day, usually 1 egg per nest. So she's working all summer, and then the adult female will die, but the eggs, depending on your species, the egg will start eating that pollen mass and pupate. Is it larva? Pupate first. They'll go into
The larva
metamorphosis.
eats the pupates.
Okay, yes. I had that wrong one time, and now every time I say it, I'm second guessing myself. So depending on the species, they'll overwinter as a larva or a pupa, and then they'll emerge next year as an adult once the conditions are right. And with a lot of native bees that are specialists that look out for specific plants for their pollen diet, they'll emerge at specific times of the year to coincide with the blooming of those plants. So like those willow species, they're going to be done by May or June, whenever the willows are done blooming. The hibiscus bee doesn't even come out until July. So it's just different timing.
Okay. And then Joey said, I've seen people restoring farmland to wetland really emphasize destroying old clay tiles. Is it really that important to do?
Yeah, so the clay tiles were put in obviously to drain the wetland. So I feel like it depends on the project. If you can somehow incorporate the clay tile drainage into moving the water to a specific swale or place that you want, I don't feel like you'd have to destroy all the clay tiles. But if you're needing the water to really sit there and stay there for a long time, then yeah.
Hey, Jenny, this is Danielle. I have a question. So a lot of the urban stormwater management practices are kind of intended to, to get wet during the rainstorm, and then within a few days they get dry, largely because people are afraid of mosquitoes, and so they don't want to have standing water around. Is there any risk of that sort of a management causing kind of like bees might go to the area and then end up not having water available? Like kind
That's
of
a good
making a
question.
sink for
Yeah.
the bees?
Yeah, that is a good question. I've seen bees get water from mud, and I've seen them get water off of vegetation. So it is a risk, definitely. I mean, I've definitely seen them like in some of my sites, the main water source dries up, so they have to go fly and find something else. But they're pretty resilient, I would say. And also, if they don't have water, they can get nectar, at least to stay alive. They need water for nest building, so it might just be that they're gonna decrease the amount of nest building they're gonna be able to do in dry periods.
Okay, does anybody else have any questions? Okay, Patricia asked, do you see that in urban wetland restorations, appropriate plants are being used specific for specialist bees?
That's a great question. It really depends on where you're at. I feel like, so I'm married to an engineer, so I can say this. I feel like engineers are like, once they find something that works, they're just going to stick with it. So it seems like in the St. Louis region specifically, the engineers who are putting in these detention basins and things have found that hibiscus works, and they're sticking with it. And it does, it works. It's a native plant. It's clearly supporting specific bees and other things. So it does work. That being said, the problem with wetland restorations is that usually if somebody's doing it, they're doing it for a project, and they only get monitored, at least for project specific wetlands, for 5 years. And after that, it's kind of up to the discretion of usually people just walk away unless the developers put more money towards monitoring the wetlands. So in that case, after 5 years, invasive species can crop up. Other plants can just take over that might be native or might be aggressive. Like I've seen a lot of wetlands just kind of turn into cattail wetlands. Phragmites is an invasive plant that's really problematic in the area. So I would say at the start, there's good intentions and usually the appropriate plants are being used, but the maintenance is what changes the plant composition.
Okay, any more questions?
Well, it's not exactly a question, but the point about that Jenny was talking about earlier about difference in the timing of life cycles in different parts of the world. Much of the tropics is also seasonal, and surprisingly seasonal with regard to flowering periods. So specialist bees are probably tied to that annual thing. But what came to mind when that topic came up was desert bees, which will stay in diapause through a series of drought years, during which there's very little of their favorite plants. And so they can go, some of them have been recorded going 6 or 7 years between, just as some sort of a prepupa or whatever that doesn't come out because the soil doesn't get wet enough to stimulate them to complete development into an adult or whatever, which is really an amazing thing to think that they can do that without starving, on whatever resources they have. But anyway, just fascinating little factoid.
That is, I'm glad you brought that up. That is pretty crazy how long they can stay and be totally fine. And it's like they just, I guess precipitation, they just know, okay, this is the year, this is our year, we're going to come out now.
Soil moisture patterns, apparently.
Yeah.
Yeah.
That's really cool.
Okay. If nobody else has any questions, we can start wrapping this up. So thank you everybody for coming tonight. And thank you, Jenny, for the great presentation. Before you guys go, I just wanted to mention that we have our first 2 virtual training events for our winter chloride monitoring program. And the first one's going to be held a week from tonight. And then in 2 weeks, we have our final fall speaker series for the year. And that's going to be Peggy Doty from the Illinois Extension. And she's going to be talking about her recent experience working with students who discovered a water quality issue at their school and how they went about dealing with that. And if you're interested in registering for either of those events, you can find them on our webpage or on our Facebook. So thank you everybody for coming, and thank you, Jenny, for the great presentation.
Well, thanks. Yeah, thanks for having me.
Yeah.
Thanks, Anna. Thanks, Jenny. Thanks, Danelle.